Hi. So in this session, we will look at the VPC connectivity and internet gateways. So there are different ways VPC can be connected. So why is connectivity needed? So that it can talk to other systems or it can talk to a data center or in premises, and it can also talk to different systems on the internet. That is also important. So let's look at the internet gateways. So VPCs can use internet gateways to talk to the internet. For example, take this scenario: you have a VPC, this VPC, and you have an instance inside that VPC. It means that instance has launched using that VPC and the subnet of that VPC. In order to connect to the internet, this cannot connect to the internet directly. So there has to be a gateway in between to connect it to the internet. This gateway is called Internet Gateway. You can say IGW as well. So what happens is IGW, in order to make it highly available and redundant, the reason for that is if you have, you know, different instances and all routing to the same internet gateway, which is only on one AC, and if that internet gateway fails, then all the communication stops. So a standard process is you create multiple gateways in different ACs, and that should be used because that is a fault tolerant approach and it is highly available. So how it will look like is if you have multiple VPCs, so they all will be routing through different internet gateways, and these internet gateways might be on different ACs. Okay, so there are no bandwidth constraints, and so from a bandwidth perspective, it can talk to the internet. There are no constraints on that. So each VPC can be assigned a elastic IP or a public IP for inbound and outbound communications. Now let's look in detail how the internet gateway will allow traffic to be flowing um, to the internet. So usually what happens is we first create a VPC. This portion, we first create a VPC. We uh, block certain CIDRs as a part of that VPC. And then the next step is we create subnets. There might be one subnet or two subnet. So one thing to important to notice, like when you create a VPC and you are mentioning a CIDR, so you, for example, when you create it the first time, you will have to mention a CIDR. Just like this example, you see the screen here. This is the place where you provide a CIDR in a range. So this blocks the network and those IPs, and your subnets has to be a subset of what is provided here. So these CIDRs, there can be max of 5 CIDR associated to a VPC. So once you create a VPC with the CIDR, you can edit the CIDRs and you can add more CIDRs. Okay, and here if you see the tenancy, it is default. You have two options. One is default and the other is dedicated. Dedicated would attract money. It has extra charges associated with it. Now these CIDRs, when you put a range, the range has to be minimum /28 and maximum /16. So this should be the range. So what will happen if you use /15? This will give an error. It will not allow you to create a VPC if you give /15. So let's look at this again. So what happens is you have a VPC, you can create up to max of 5 CIDRs. You create a subnet, you can create up to 200 subnets for this VPC, and you can mention CIDRs as a part of these subnets. So always remember, whenever whatever CIDR you have mentioned here, this is the outer boundaries. So whatever you mention in this place, there should be a subset of what is here. And the next step we do is we create a EC2 instance. We provide VPC and subnet. So let's look into it. First, also let's look into the screen of subnet and where do you provide the CIDRs. You have to select the CIDRs. So where do you do that? Let's look into it. So this is a screen where you create subnets. And here what we're doing is we created a subnet, and then by the process of creating we gave a name tag, and then we selected a VPC, and that VPC had two set of networks or IPs. So we just chose one to associate. That's why you see this is associated to the network and this is disassociated. You can select an AEC where you want to put these CIDRs on, and then you can give a range of IP addresses for the subnet, which so this should be a subset of what you have mentioned in the at the time of creating VPC. So now let's look at when we create a EC2 instance, what are the options we have? Primarily, two things you should provide whenever you create an instance. It's a part of VPC, so you have to choose under which VPC you want to create the instance, and you have to choose the subnet as well. Let's look at the EC2 instance creation screen. So when you try to create an instance, you have to choose an an AMI, etc. That's a step 1 and 2. So here I have displayed step 3 where you select a network. Network is either your VPC, and then the IPs associated with that, the subnets associated with that VPC will be visible here, and you can select it. So for example, in this case, you have selected a subnet, and you get a display message that 251 IPs will be available. Now, so far so good. Now your instance is created. Okay. Now what do you do? Your instance cannot talk to the internet. So in order to make it talk to the internet, you need an internet gateway, and that's your hero comes in. You have to put an internet gateway. So how will the internet gateway know that which VPC it has to provide internet access to? So that's why when you create an internet gateway, you have to attach a VPC to the internet gateway. Let's look at that screen as well. So in this case, we created an internet gateway, and now this screen we are showing the process of attaching a VPC. This is how you attach a VPC to an internet gateway. Now, if you get a question in the example that you have created an internet gateway and still your instances are not able to talk to the internet, you should always remember that internet gateway alone cannot help you talk to the internet. You have to create routing tables. That is important. So what do you do in routing tables is you associate subnets and create routes there. So let's look at how do you do that. So what happens is, suppose, take an example where you created a private subnet and a public subnet. You gave a IP range. So in the route table, for example, you have 10.0.0.0 slash something. So anything that starts from that IP is local. So if you see in your route table, it will be defaulted local. And you can add a new row where you say anything which is other than this, that is 0.0.0.0 slash 0. If any other IP would be routed to the internet gateway, and that's how your routing table through your routing table the system will understand that this is how which IPs to keep within the network of AWS and which IPs they can route it to the internet. This is how it will be clear. So Always remember internet gateway with routing tables helps you talk to the internet. Internet gateways alone cannot help you talk to the internet. Now let's look at what are the different ways to connect to a VPC. For example, like I have explained three scenarios here. For example, if you have a VPC and you want to talk to the internet, we saw in the previous example that you should use a IGW, that is your internet gateway. But if you have two VPCs and two VPCs needs to talk to each other, then you should use VPC peering. This place, VPC peering. Okay. Now there can be business scenarios where the client has its own data centers in premises, and those data centers needs to talk to the VPC or some instances on that VPC. So how to do that? So in this case, what is important is the first thing you can do is establish a site-to-site connection. If you do a site-to-site connection, you do not need internet gateways, NAT gateways, or any such sort of things. So what site-to-site does is it creates a private network, and all the data in motion and at rest is encrypted. Another way to do it is via the virtual private gateways. You can also have a virtual private gateway through which your VPC can connect to your data centers in premises. Okay. Now let's look at another scenario where your VPC needs to talk to different AWS services. For example, S3, DynamoDB, and so on. So how they do that is one of the common methods. Always remember is VPC endpoints. So endpoint is a very common method to connect to these AWS services. But you can also do it through internet gateways, NAT gateways, virtual private gateways. You can also do it through that. But VPC endpoint is the most popular one. Let's look at some scenarios here. For example, you have two EC2 instances on the same region, and if both are using public IP, then the question here is, will the traffic flow to the internet or it will remain within the boundaries of the AWS network? So the answer is it will remain within the AWS network. It will not, the traffic will not flow to the internet. Take another example where you have two EC2 instances but in different regions. This is a different region, okay? Do not see a same region. So in this case, what happens is, so in this case, you will see the EC2, like if both have public IPs and if there is a VPC peering between these two instances, then the traffic will not flow to the internet. But if VPC peering doesn't exist, if VPC peering is not existing between these two instances or the VPCs under which they reside, then the traffic can flow to the internet. Now let's look at a few important concepts. The first one is what is the IP address range assigned to a default VPC? So we saw examples where we created our own VPC. But the question here is if when you create an account, it gets a default VPC. So that default VPC, uh, the CIDR assigned is this one 172.168.0.0/16, and the default subnets, the default VPC under the default VPC, it use a slash 20 net blocks. And the one is how many subnets I can create per VPC. So this is a very important to remember for the exam. You can create 200 subnets, but whatever IP or CIDRs you use, it has to be within the boundaries that you have defined when you created a VPC. Take this question where it asks for if you can change a private IP address of an EC2 instance. The answer is no. The primary private address cannot be changed. Only the secondary addresses can be changed. primary addresses stay with the instance for the lifetime. On the similar ground, there is a next question where it says if an EC2 instance is stopped within a VPC, can I launch another instance with the same IP? No, you cannot do that because that IP has been taken by the first EC2 instance and that stays for life. So the next question is, can I assign multiple IP addresses to an instance? You can, but there is always one primary. The secondary can be many, but the primary can only be one. Uh, let's look at another question. So can I assign one or more elastic IPs to VPC based EC2 instances? I can. The elastic IPs I can, but one thing to remember is uh, elastic IPs cannot be used on instances along with NAT gateways. Okay. Can Amazon EC2 instances within a VPC communicate with Amazon EC2 instances not within the VPC? It can communicate, but you need an internet gateway. So always remember, if something is not within AWS, so it always has to be internet, and the only way to talk of, probably for public subnets or with instances with public IPs is via internet gateways. Can Amazon EC2 instances within a VPC in one region communicate to Amazon EC2 instances within a VPC in another region? It can communicate through a inter-region VPC peering. That this is very important. But there are other mechanisms as well. They can also communicate through public IP addresses, NAT gateways, NAT instances, VPN connections, and direct connect connections. So between these two regions, we can create a direct connect connection. We can create VPN connection, or we can also route it through NAT gateways and instances. So there are multiple options. With this, we come to an end on this topic. I'll see you again for the next topic. Thank you.